everyone. Am I audible to you?
Yes, sir.
Okay. So I want everyone please be attentive in the class, and I will share the programs, that is MATLAB programs for optimization today, and some meta heuristic process of optimization, means in industry how they optimize for large or big problems. Okay, so when the number of variables and number of constraints are very large, so they need to use some AI based algorithms or meta heuristic based algorithms to optimize the problem, okay, to optimize the model. So that model doesn't require any proper mathematical means global formulation, okay, global optimal formulation. So they require some other algorithms, you need to develop them. They won't give you exact solution, but near equal solutions or near optimal solutions can be obtained by them. Okay, so our today's class, we will, our objective is to learn how to develop the program in MATLAB by using um, the existing MATLAB algorithms, optimization algorithms. Okay, and the most efficient optimization algorithm which exists in MATLAB is fmin-con. I already have just gave you a little bit idea how fmin-con works, okay, in the last class. So in today's class I will give you a thorough idea, means how it works and how the genetic algorithm also works. Okay, genetic algorithm is also another meta heuristic based algorithm. Okay, so which actually based on um, the genetic, the theory of genetics, or the evolutionary algorithm, it also says. That is how evolution works, how human evolution and other creature evolution works, exactly based on that phenomenon this algorithm was developed. Okay, so let me just give you first local and global optimum idea, what is local optimal and what is global optimal solution. Okay, then I am going to the proper MATLAB programs first. Okay, let me share the screen. uh, Screen visible to all of you?
Yes, sir.
Okay, so local and global optimum, so optimal solutions. Okay, what is optimal solutions? I already have given you the idea. Objective function, let us suppose the objective function is x1 square plus x2 square plus x3 square. This is the objective function, and subject to the constraints, subject to the constraints, let us suppose 2x1 plus 3x2. Okay, okay, objective function, let us suppose it is minimization, minimize this, minimization type of problem. Okay, so 2x1 plus 3x2 plus x3 is let's suppose it is greater than equal to 1. X1 plus x2 plus x3 is equal to 2. Is my screen visible to you?
Yes, sir. It is visible.
Okay, just wait. OBS. Yes. কিছু দেখা যাচ্ছে আমি খুলেই করছি না। Okay, so ওটা না করে আমি কাজ করবো কি করে? হ্যাঁ, okay, so this is the first and second constraints, constraint 1 and constraint 2. Okay, and this is the objective function, and let us suppose there is another nonlinear constraint also exists. First nonlinear constraint is like this: x1 square plus x2 square plus x3 is let us suppose it is greater than or equal to 5 3. So three constraints are there. You can see the first constraint is inequality constraint, but linear inequality. The first one is linear inequality. Second constraint is linear equality constraint, and third constraint is non-linear inequality. Okay, now there are two kinds. If you solve this problem, there are two kinds of solutions you may get. First solution is called global optimal solution. Sorry, global optimality. Second one is local optimality. Okay, so what is global optimality? Global optimality means, let us suppose, just I am giving you an example, we are going to find out a solution of this kind of graph. Okay, let us suppose the graph is like this. Okay, just the graph is like this. Okay, this. So you can see, basically optimality, if you use the function, means any kind of mathematical formulation or mathematical method to solve this problem, what they do, they are basically searching for these peaks. If you want to find out the maximization problem, let us suppose the problem is maximization. Okay, So maximization problem means finding out these peak of this mountain. Now how many peaks of these mountains are there? This is first peak, this is second peak, and this one is the third peak. Okay, so first peak, second peak, and third peak. So all these three are optimal values basically. Okay, maximum values. So this one is also a maximum value, this one is also another maximum value, this one is also another maximum value. Okay, so but the function doesn't mean that this function, the global maximum of the function is always 1. Global maximum means the highest peak of this function. Which one is the highest peak? First, second, or third? The first one is the highest peak. Okay, second and third, these are not the highest peak of these functions, but they are the peaks. So all peaks, whatever the peaks exist for any function, all peaks are called local optimum or local optimal solution. So this is also a local optimum, this is also local, this is also. So which one is global out of them? This is the global. Understood? So global, this is the difference between the global optimum solution and local optimum. So optimality, it basically, it's actually creates a method to find out the peaks of a function. Okay, peaks. So if a function has multiple peaks, okay, there is sometimes there is a chance that the optimization process may fall under the trap of finding the local optimum. Okay, it means that sometimes the function, it is basically, if you find out any search algorithm, so what it needs for each, this is the x-axis and this is the y-axis. So for each and every point of x-axis, it is just the point is searching. Okay, it's searching for the highest value. So let us suppose this point is 2 and this point is 4. So you have given the range 2 to 4. Okay, so if you have given the range 2 to 4, so it searches for each and every point. Okay, it search for the optimal values, it means the functional values. So which functional value, it is the highest functional value, this is the value, this is the peak. So functional value at this point, let us suppose it is 2.3. So at 2.3, okay, or it is 3, let us not 3, or 2.8, let us suppose. Okay, so 2.8 point, this functional value, this y value is the maximum. Okay, so this is a local optimum, not a global, but because you have given the range only 2 to 4, so the search, that is the optimizer, it searches only in between this range 2 to 4, which value is maximum. So in between 2 to 4, this is the highest peak, but it's stuck into the local optimum only, not the global optimum. Okay, so sometimes, so what happens in case of any search algorithms or this kind of algorithms, sometimes the optimizer may fall under the trap of this local finding of only local optimum. Okay, because you have given the range only between these. So global optimum, if you really want to find the global optimum, your search space should be bigger. Okay, but mathematically, if you find any mathematical mathematical methods means finding of derivative, okay, which is called the classical optimization process, or finding the derivative of the function. Okay, and then finding the second derivative of the function in case of multiple variable, Hessian matrix finding, that is another method. Okay, so in that method, the function, it may means the search space is bigger, means minus infinity to plus infinity. So all kind of local optimum you can find there if you just just take the derivative of this function. All peaks, you can find all the peaks, because at the peaks the derivative, it becomes 0. So the derivative method can give you each and every point, each and every point of x where it gives you the peaks. So every point you can get, okay, in case of derivative or proper mathematical method, and then you can find the second derivative, and then you can use that all the points means put it into the function and find which one is the global. Okay. So if you use the proper mathematics, okay, or classical optimization, then you can find the there is a chances of finding global. But in case of if you made an algorithm which is not based on this kind of the derivative or Hessian matrix or second derivative method, you can use any meta heuristic like genetic algorithms or particle swarm algorithms, PSO. Okay, then there is a chance they cannot give you a proper means global solutions. Near optimal solutions you can get because they are not using that evolutionary algorithm doesn't require to find out the means derivatives and finding out all the peaks. Okay, so this is the idea of global optimum and local optimum. Okay, so now let us I'm going to going for the MATLAB directly. Is the screen visible?
Yes, sir.
Yes, sir.
Okay, so this is method I told you. So one by one I will give you the example. This is one of the example. Okay, let us go for the GA, go for the FMIN. Okay, do right now do not see or do not look at the this percentage symbol means green colored commands. Okay, right now I am just inactive. I have means deactivated these green color codes because right now I am not going to explain this. Okay, one by one I will explain. So first look at this is the objective function. This is one of the examples which I already given you in the last class. So this is your objective function. Now look at A and B. This is linear inequality. Linear inequality. So just look at A and B. This is the A matrix and this is the B. So can you tell me what is the constraint? A matrix is 1, 2, B is 1 only. Okay, there are two variables x1 and x2. Look at the objective function. There are two variables. Okay, so two variables, that is why you can see the matrix dimension is also 2. That is number of column is also 2. So number of column is 2, it means only two variables are there. So can you tell me what is the first constraint? Just look at these two, capital A equal to 1, 2, B equal to 1. So what is the first constraint? Write down in the chat box, please. 1. No, first constraint, the entire constraint. Is 1, 2 means 1 into x1 plus 2 into x2. Right, the first constant is 1 into x1 plus 2 into x2. It is already written here. Look at this first one, it is already written here. 1 into x1 plus 2x2. Okay, it is basically less equal to, it is the symbol is changed here. It is less equal to 1 because I already told you in MATLAB constraints all the constants, they are taking the less equal to symbol. Okay, so if there is any greater than equal to symbol, you need to convert the constant into less equal to symbol by multiplying minus symbol both sides. Okay, so first constant. What is the second constant? Second constant is equality constant. You can see 2x1 plus 2x2 equal to 3. So okay, so AEQ matrix is 2 and 2 and 2, because the coefficients are 2 coefficients. And what is the BEQ? BEQ is 3. BEQ is 3. Lower bound and upper bound is not defined here. Okay, so because the function x and y values lower bound and upper bound, we didn't define it. So we just left it for the function only. So x0, 10, 10. X0 means the initialization, which it must require. There is no non-linear constraint, so that is why non-linear constraint I just put it this blank matrix. Okay, something is missing, it means a blank matrix you need to write here. Okay, and what is the code? This is the code, x equal to f min con. Okay, so we are using f min con function. There are other functions also, f min con. Okay, and this is the code for this function, means the objective function x0. Okay, exactly you need to write according to the same sequence. Do not write any other sequence. Okay, x0 capital A B A E Q B E Q. Okay, now run it. So it is already you can see this. So I need to print x values. So this is the x value. Look, this one. Understood, everyone? Now look at this. These are the strategic decisions. Means x1 value is 2 and x2 value is minus 0.5. x2 value is minus 0.5. Okay, can you tell me the functional value? Means what is the minimum value of this function? The function is this. This is the function 100 into x2 minus x1 square whole square plus 1 minus x1 whole square. Can you tell me, based on this is the x1 value and this is the x2 value, what is the functional value, that is minimum value of the function? Just put x1 and x2 value in this function and tell me. Write down the chat box. Everybody please be attentive, and if you are not understanding anything, then you can just tell me. I will explain this one again. No answer. Am I audible to you? Am I audible to you? Okay, explain again. Look at this. What is the x1 value? What is the value of x1? 2.0. What is the value of x2? Minus 0.5. Okay, and what is the function value? Let me look. What is the function here? The objective function. What is the objective function? Objective function is 100 into x2 minus x1 square, 100 into x2 minus x1 square whole square. Okay, and plus 1 minus x1 whole square plus 1 minus x1 whole square. This is the objective function, right? 100 into x2 minus x1 square whole square. So yes, this is the objective function. Okay, here we get x1 equal to what? X1 equal to 2 and x2 equal to minus 0.5. Now I am saying what is the value of this function based on these two values. What is the value of this function based on these two values? Calculate and tell me. That is why what I am saying. Okay, so it means 100 into what is the value of x2? Minus 0.5 minus what is the value of x1? 2 square whole square plus 1 minus x1. What is the value of x1? 2 whole square. Calculate this one and tell me the value. What is the value? Do you understand now?
Yes, sir.
Understood. So this is the optimal functional values. Your strategic decisions are x1 and x2. X1 and x2 are your strategic decisions. So based on that decision, what is the function objective value, objective function, minimum value of the function? And this function, let us suppose this is a cost function of a company. Means a company is going to reduce the cost, or based on which strategy, what kind of strategic decisions company should made so that the total cost of the company is reduced. Okay, so if the company made the decision x1 equal to 2 and x2 equal to minus 0.5, let us suppose these were the investments of different sectors. Okay, this is the labor sector. X1 is the investment in the labor sector. Let us suppose the investment is let us suppose it is $2 million, and x2 is equal to minus 0.5. So let us suppose this is also another investment. So minus 0.5 investment means they need to reduce their investment. Okay, so minus $0.5 million they need to reduce their investment. So based on if they use these two strategic decisions, so what should be their cost now? Their cost should be this. So this is called the optimal cost of the company. So all these are the based on these two strategic decisions, the company can reduce the cost up to this. Understood? So now again I am going to the MATLAB. So to visualize the optimal value of the function, okay, we can use another code. The code is this: x comma f val. Okay, x comma f val and this. Okay, so x values are already now, if you run this, okay, this one now, x value, just put here x. These are the values of the strategic decisions. Now f value means what is the reduced cost. Okay, what is the minimum cost they can obtain. Okay, so f val, so this is the minimum cost they can obtain. So 2.026 into 10 to the e plus 03, it means 10 to the power 3. So 10 to the power 3 means it is 2026. 2026 is the uh, minimum cost, $2026 million. Understood, everyone? Okay, now let us explain some example with non-linear constraints. Okay, nonlinear constraints. Okay, function is this one. I'm going to neutralize the function. Our new function is this. Okay, 100x, the same function is used here. 100x x2 minus x1 square whole square. Yes, yes, the same one. This same function, no need to write this one. Same function is used. Same function, let's suppose the same function is used, and but there is no other constraint uh, except only a nonlinear constraint. The nonlinear constraint is this. This is the only nonlinear constraint. Okay, this one. Forget about this. This. Look at the nonlinear constraint here. What is the constraint? Please write down in the chat box. Just simply x1 and x2 form. So x1 square plus x2 square less than equal to 1, right? X1 square plus x2 square less than equal to 1. So tell me first, everyone, I am requesting, please answer, what kind of nonlinear constraint is it? Is it nonlinear inequality or nonlinear equality? Which one? I have given you two options. Look at the constraint and tell me, is the constraint a nonlinear inequality or nonlinear equality? X1 square plus x2 square less than equal to 1. Nonlinear inequality. Exactly. Nonlinear inequality. Okay. So it means that only one constraint is there. No other constraint is there. So nonlinear inequality, and there is no equality constraint there in the problem. Okay. Also, other constraints, it means that I am also deleting the other constraints. I'm not for the just for the sake of simplicity, I'm deleting all other constraints. A, B, AEQ, BEQ, nothing is there. Okay. A, B, AEQ, BEQ. Okay. LBUB just okay. X0, let us suppose it is 0, 0. 0, 0. Okay. Now nonlinear constraint, to define the nonlinear constraint. Okay. Let us define a MATLAB, another function file of the MATLAB. We will call that function here in nonlinear constraint. Okay. So how to create a function file, just like C or C++ programming, we can use a function in MATLAB. So let us create a file here. To create a MATLAB function file, we need to write it like this. Function, okay, just like this. Just copying and paste it like this. Function, okay, just like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. Function, okay, just copying and paste it like this. this. So you can see, if you start any MATLAB script file with a function writer, so it means MATLAB will understand that you are going to create a function file. Okay, and as you know, every function has an input and output. Okay, so this function, if I write here function in a bracket CCEQ, it means how many outputs are there? There are two outputs, C and CEQ, two outputs are there. Okay, and unit disk is nothing but the name of the function. Whatever the name you are using here, you are using unit disk, so you need to save this file exactly in this name, unit disk. Okay, exactly by using this name. Understood, everyone? If you are having any doubt, then please tell me. This is very important thing. Any doubt for anyone? Okay, now just look at the function, and I already told you there are two outcomes, C and CEQ. Okay, how many arguments are there? How many arguments or input variables are there? Yes, one. But remember, one means you are just to see the x, and you are saying the input variable is one only. But x is a vector here. So in x vector, we are using two different components, x1 and x2, right? Okay. So if you consider x as a vector, just so the input variable or the argument is one only based on the vector representation. Okay. But in case of scalar representation, x1 and x2, there are two different, in x variable, there are two different variables, means x1 and x2. Understood? So two representation you can use here. Since according to this function, if you just see the function CCQ unit disk x, then according to the function you can say that yes, there are two outputs C and CQ, and one argument or input variable is there x. Understood? Now I am defining the function. So how to define the function here? So defining functions, there are two outcomes, so you need to define two outcomes here. C is equal to, now go for the previous, what is the constraint? x1 square plus x2 square. This is very important. Okay, what I am saying now, very carefully listen to me, because this representation is very important here. X1 square plus x2 square less equal to 1. Okay, first you need to see what kind of inequality is this, less than equal to type or greater than equal to type. If it is less than equal to type, don't do anything, everything is okay. Okay, what you need to do, just this one, just put this one, okay, from right hand side, keep it to the left hand side. Okay, and right hand side should be equal to 0. Okay, so right hand side equal to 0, and you are keeping this 1, or you are bringing the 1 to the left hand side. So how it becomes? It becomes like this. Okay, x1 square plus x2 square, okay, minus 1, okay, less than equal to 0. Do you understand this statement? Everybody understood this statement, yes or no?
Yes, sir.
Okay, I'm asking for everyone. Okay, so it means that so whatever in the right hand side, put it or keep it to the left hand side. If it is less than equal to, now let us suppose it is greater than equal to, then what can it be done? Let us suppose it is greater than equal to. So first what you do, you need to change the symbol to less equal to symbol. And how can you do this? Just minus symbol, just multiply minus. This becomes minus, this becomes minus, and this becomes minus. So if you multiply minus sign both sides, the greater than equal to symbol will be converted to less equal to symbol. And now in the next, what you do, minus 1 should be transferred to the left hand side. Okay, and left hand side should be equal to 0. Sorry, right hand side should be equal to 0. So it becomes minus x1. Just everything, whatever in the right hand side, keep it same. Don't change anything. Okay, both are minus minus, and minus 1, if you just shift minus 1 to the left hand side, what happens? It becomes plus 1. Plus 1 less than equal to 0. Okay, so for greater than equal to symbol, you need to first convert the symbol to less equal to, then make right hand side equal to 0. Whatever the component or whatever the number present in the left hand side, sorry, right hand side, just shift it to the left hand side. Understood? So but we don't use this one because our it is less equal to already. So what we do, we just put it x1 square plus x2 square minus 1 less equal to 0. Okay, so what is our constant? So our constant c equal to, we will write x1 square, okay, plus x2 square minus 1. Done. Understood? So x1 square plus x2 square minus 1. Now less equal to 0, no need to write. Don't write less equal to 0, because you already means the right hand side you already made it 0, and all the numbers from the whatever the numbers exist in the right hand side, you already shifted the numbers to the left hand side, and this will be your constraint. Don't write less equal to 0. Understood? Now what you do, CEQ. Okay, now CEQ. Now how can you write CEQ? There are two different outputs are there. One is for C is for nonlinear inequality. CEQ is for nonlinear equality. So nonlinear equality, what do you do here? Since there is no other nonlinear equality, so CEQ is equal to just blank matrix. Okay, your task is done. And sorry, so this is how you can create a MATLAB function file for nonlinear constraint. Okay, but you need to save the file. So look at this file is saved as untitled. So untitled MATLAB file, there is no significance for that. You need to save this file by using a name. So let me save the file. What is the name? You need to use unit disk. Already look at this, already it came like this, unit disk. You don't need to write anything. So whatever the name you have written here, you have written unit disk. Already the unit disk is displayed here. So now just save it, unit disk.m. okay, it is already set. Now go to the main function. Okay, so nonlinear constraint. So non-linear constant, you just to call the function. How to call the function? You here in MATLAB, to call any function, you need to write @ and and the name of the function. What is the name of the function? Unit disk. Okay. Now since AEQ, BEQ, nothing is used here. Okay. So AEQ, BEQ, uh, capital A, capital B, no constraint is there. So since capital A and capital B, no constraint is there, you can just use capital A is equal to blank matrix, but you need to define everything. Okay. Okay. Small b equal to blank matrix. Okay. AEQ is equal to blank matrix because no constraint is there, and BEQ is equal to blank matrix. Okay, nothing is there. Okay, lower bound, upper bound also nothing is there. X0 we have initialized as 0 0, nonlinear constraint at unit disk. Okay, now x f value equal to f min con function a0 b0 bq. Okay, here you need to use this one. Now next one, later one, this. Since there is nonlinear constraint, so because nonlinear constraint is there, nonlinear constraint function x0 a b aeq bq lb ub nonlinear constraint, this one. I'm not using options here. Option is used for different things. Okay, this. Okay, now if you run the program, okay, now what is the function value? These are the two function values, means strategic decisions. X1 value is 0.7864, x2 value is 0.6177. Okay, and what is the f value? It is a functional value. The function value is main thing here. Okay, f value 0.0457. Okay, now tell me, any doubt? Any doubt for anybody?
Sir, can you please explain why the AEQ values are 0?
AEQ. Okay, AEQ and BEQ, these two are the linear equality. Okay, capital A is represents linear inequality. Okay, AEQ linear equality, but this particular function, okay, this particular function, there is no linear inequality, no linear equality, nothing is described here. Means only the single constraint, which is the nonlinear constraint, nonlinear inequality constraint, is present in this problem. No other constraint is given. But uh, when you use the function, means the code, the program code, so according to the program code, the sequence function x0 capital A capital B aeq beq, this particular sequence you need to maintain. Okay, if you don't maintain because the fmincon function is already in MATLAB package, already it is defined. So according to the program of fmincon, this sequence, these arguments are sequenced like this. Okay, so you must need to write down, put everything, function x0, linear equality, linear inequality, lower bound, upper bound, then nonlinear constraint. So nonlinear constraint appears after writing linear constraints LB, UB, means lower bound, upper bound, everything. But here in this particular problem, capital A and small b, AEQ, BEQ, nothing is there. Okay, means no other constraint is given except only the nonlinear constraint. So how to define the nothing is given? So how to define AEQ and BQ? So use simply the blank matrix. So capital A is equal to the blank matrix, capital B is a blank matrix. Okay, AEQ blank matrix, BEQ blank matrix. Okay, Since it is a blank matrix, if you are using the blank matrix, then the MATLAB automatically will understand that no constraint is given. Now do you understand? Hello.
Yes, sir. Thank you, sir.
Okay. Now next task, how to plot the plot functions, means graphical representations. Okay. Since fmincon fmincon it uses some algorithms. Fmincon, the use of fmincon functions is based on 4 different algorithms in MATLAB. Okay, let me explain. The 4 algorithms in MATLAB are like this. Okay, okay. Another things I need to show you. This is called optimization toolbox in MATLAB. You no need to write down the don't need to write down any code. Okay, just go to the apps section. You can see all kind of toolbox are present. Curve fitting, optimization, okay, signal analysis, image acquisition. Um, so if you look everything, neural network clustering, neural network fitting, neural network pattern recognition, neural network time series. Okay, optimization. So optimization toolbox, you need to select optimization toolbox here, and the toolbox will be opened here. So here in optimization toolbox, look at this, all kind of solver is present. So we are using the solver fmincon. So you need to select fmincon. Now fmincon uses 4 different algorithms to find out the maximum or minimum point. First one is interior point algorithm. Second one is SQP, which is sequential quadratic programming. Third one is active set. Fourth one is trust. Okay, trust region reflective. Now which algorithm should be used here? So it basically we are using the algorithm based on the problem type. Okay, generally if you want to minimize the time or minimize the number of iteration of the algorithm, you can use the SQP or sequential quadratic programming. Okay, so these um, algorithms you can change according to your need. Okay, so we can also SQP, you can also select SQP here. Now objective function, you can use the objective function here. What is the objective function? Directly you can put the objective function here at the rate x this. Okay, this objective function you can also put here. Okay, or you can use a function file, you can create a function file, and the objective function you can define there, and you can use the objective function here at the rate of the name of the function. Okay, now derivatives approximated by the solver and gradients applied, these two things are there. Okay, starting point, it means the initial point, x0 point here. A matrix for linear inequality, B for linear, B for it is linear inequality right hand side, AEQ, BEQ, lower bound, upper bound, everything you can put it here. Nonlinear constraint function, you can put it here. Okay, here also approximated by the solver you can use, and then you can start it, and the algorithm also give you the solutions. So here different graphs are there. Different graphs means according to the algorithm, each and every iteration, okay, how the algorithm works, how many iteration are needed, and every iteration the graphical plot function is created here. So that is why we are using this options. Okay, look at this. So options, it is, options means all kind of criteria what you need to use in these particular algorithms. Okay, so first option, you are using which solver is you are using, what kind of solver you are using, fmincon solver. So at the rate of fmincon you need to write here. Next, algorithm. Okay, comma algorithm. So what algorithm you are using, interior point. If you want to change this algorithm, just change it here. Interior, I will give you the example for other algorithms also. First, interior point algorithm, let me give you the explanation. Then plot function, plot fcn means plot function. Now which plots you are needed? First, optimal plots means every iteration what is the functional value, the optimal plot will plot this. Okay, optimal plot eval means the function value. Each and every iteration what is the optimal plot function value they will give it. Optimal plot first order. Okay, first order opt. So first order opt, first order options, okay, means derivative supplied values it will plot. Okay, so let me use these options now. So after putting the option, after nonlinear constraint you need to put here options. Okay, means this option you need to put it into the function file. Now I am running it. Look, what are the two values? One means x1, 2 means x2. The first value is this one. Okay, second value is this. These are the graphs of first two, since there are two variables only, so x1 and x2, these two values. Okay, iteration, how many iterations? Look at the iterations. So this much amount of iterations are there, and this much amount of, these are functional values. Okay, so if the algorithm is convergent, you can see at the end of the iteration all points are almost similar. Since the algorithm is convergent, so points will also be convergent at the same point. You can see all points are becoming parallel at the end of the iteration. So up to 15, to 20 to 25, 15 to 25, you can see all points are giving almost the same values. It means it is evident that yes, the algorithm converges. It is not a divergent algorithm. Understood? Now you can see the number of iteration is large. So how to reduce? If you change the means algorithm, if you change the algorithm from interior point to other algorithm, so I have used interior point. Instead of interior point, I am using suppose SQP, sequential quadratic programming. Okay, now I am running this. Look, how many iteration it needs? Only 14 iteration. Okay, only 14, and only 14 the function gives it the same value. Understood everyone? So this is a comparison you can see. Okay, so which iteration means the less number of iteration it needed, SQP. Okay, now let us suppose the thrust region, let me active set and thrust region reflective. uh, let us suppose active set now. Look, active set, how many iterations? 20 iterations it needs. Okay, it needs 20 iteration. So interior point 25, active set 20, SQP only 15. Okay, the last algorithm used by the MATLAB is uh, which one? Thrust region reflective. this algorithm is not applicable here. So only three algorithms applicable here in this. So let us so SQP gives us the best value, right, with a less number of iteration. See, so this is the different techniques which you can use here to find out the optimal value of a function. Understood? Okay, now anybody has any doubt, then ask me. Any doubt for anyone? Please write down in the chat box, otherwise I cannot understand that whether you are getting it or not. When will the Monday, Wednesday and Friday classes starts again? Hmm? Okay, Monday, Wednesday and Friday classes. Okay, we will be receiving a mail, okay, for the regular classes when it will be started. Also, this is also a part of the class. Okay, so no question from anyone. Everybody understood? Okay, we have done the project at certain level. I want to show you. Okay, review. Yes, yes. The project review and everything. Okay, just mail it. Whatever you have done, okay, whatever the task I have given to you, okay, if you have done the task, okay, just mail it. I will check them and I will give you the review for that. Okay. Okay, so whatever the making groups of students from the same university to work together. Same university student group. Okay, okay, that Aishwarya ma'am will decide and will be intimated to you. Okay, okay, the mail ID I am writing here, the mail ID from which mail ID he will be sending the mail. Whatever the task I have given, if you have done, okay, at a certain level or certain point of them, please send it to the mail. I am writing the mail ID here in the chat box.
Research internship @innovaworld.in.
Research.safe. Okay, the mail ID. Right now, yes, right now you need to do it alone. And there is a format of outcome, okay, which is given in the website, InnovaWorld website. So whatever the task you have done, first say, mail it to me. Let me check that task and I will give you a review for that, and you will write down the report. Okay, the report format already given on the website. Okay, So sample report format already innovaworld.in website. Okay, the domain is changed now, innovaworld.in. Okay, not it is now not in .info. Okay, innovaworld.in/research. Okay, I'm writing also innovaworld.in/research. Okay, this is the uh, means URL from where you can download the sample report. Okay, so the sample report, first download it and put down all your means a task and all the outcomes on that sample report. Okay, so one by one, first I have given you the regression, I think. Okay, so the data cleaning and regression, and after that I will give you the another task for means the suppose decision tree or the neural network. Okay, so the same problem you need to use different techniques to solve it, and we need to find out, we need to compare, and we need to find out the best technique for that. Okay, after that we will be following the optimization techniques. Okay, so those who are given to the means regression for continuous variables, regression for continuous outcome variables, for those problems we will be also formulating the optimization technique, optimization problem based on some constraints. Okay, after that I need to solve the optimization problem and plot the graph like this. Okay, so that is why I am means teaching all of these techniques. Okay, so that you will not be having any issue for that. Okay, next one is if this method, sometimes if min con or something. Okay, sometimes this method, if this method taking too long time, or this method fails, then we can use some other method which based on AI techniques or meta heuristic techniques. Genetic algorithms are there. Okay, so I will explain the genetic algorithms later. Right now these are the things you need to practice. Okay, so I have given you all the algorithms. So for comparison purpose, you can use the SQP interior point. Okay, and the other one. So, okay, as also you can use the computational times. Okay, for computational time purpose, you can use this uh, code in MATLAB. Okay, just wait for 2 minutes. I'm coming. Okay. Okay, so the last thing which I need to explain, okay, uh, the computational time, okay, or the elapsed time of the algorithm, how can you find it? Okay, so that is very simple in MATLAB to find out the elapsed time of the algorithm. The function is tick and talk. So at the before just starting the program, you use tick, tick, and at the end of the program, you just use talk and run it. So what is the elapsed time? It is given here. Look at this. So along with all the functional values, you can see it is what is the function means elapsed time 0.798231. This is the elapsed time of the algorithm, right? So let us change the algorithm from SQP to interior point. Interior point. So it is, let us suppose it is 0.7982, right? Look, this is 1.086 this seconds. So from computational time also you can see that the interior point, it is taking much more time. Okay, and another one is active set. 0.83. Okay, so which one is taking the less number of time? You can see that is also SQP is taking less number of time. So simply you can use this very simple thing, tick and talk function. At the before starting the program, just use tick, and at the end you just use talk. And elapsed time is easily can be calculated from here. Understood? Now, if you are having any doubt or question, then write down in the chat box. Okay, so if you yes, first give me the means you can also means in a report format you can also write down your outcomes, whatever you have done. Okay, otherwise you can just find your outcomes also, whatever you've done, and just share me with this um, email ID, or you can just put it into the report file directly. Better you just put all the outcomes in the report file. Okay, and then you just send it to me, the email ID, and then I will give you the feedback for that. Okay, after completion of the report you need to make a paper. So paper writing, I will give you the proper instruction and proper means guidance for that, because it is not quite easy to write a paper. So paper, if you want to find out a good paper, write down a good paper and good publication, your work as well as your writing structure, scientific writing structure should be in that level, then it will be published. So I'll give you the proper instruction for that, but before that need to complete the report. Okay, if your report is complete, then the outline of your research will be decided out of that. Okay. Yes. So the number of tasks and okay, all these things I will share you. Okay, I think did I share the means data sheets to all of you? Okay, you are new batch, I think. Jatin, let me check just. There Ashirwad, Jatin, era सब new batch, na? Okay, okay. So Ashirwad, all of you are new batch. Okay, okay. So then I need to. Okay, you just wait. Let me complete the training of you again. All the trainings. Let me complete them. Then I will give you the data sheets. Okay, you have to first complete all the trainings. Means what are the tasks you need to do. After that, I will give you the data set and you need to means work on that sets. Okay. Can I use datasets of my own? Yes, you can use datasets of your own, but you need to show me the dataset first. Okay, just mail me or that is that research internship at innovaworld.in. If you have your own dataset, then first share it with the with us. Okay, let me check the dataset and your target also. What you need to actually means want to find out means what kind of project or what is your target of the project, what you will be going to do. Okay, what are the techniques you will be going to use. Okay, because in case of paper writing, okay, you need to use a sufficient number of techniques, ml techniques, and your innovative ml techniques also will be there. Then and only then your paper will be published in good journal. Okay, so first you need to share the dataset with us. We need to check the dataset and your target. What is your objective? What you need to actually do with the dataset, and that means what are the techniques you are going to apply. Okay, multiple techniques you have to apply then. Okay, let us suppose just I'm going to give you a dataset of medical science. Okay, let us suppose it is a simply any kind of disease. Okay, so any disease, whether it is yes or no, means depending on different design variables, whether the disease is yes or no, binary outcome is there. Okay, so there are different techniques you can use there. Okay, after cleaning the data set, you can use different, you can use the classification, you can use regression. Okay, you can use neural network, now neural network classification, neural network regression, pattern recognition. Okay, anything you can do. But so also you can use the support vector machine, and the decision tree. Okay, random forest algorithms. Okay, so all these algorithms are now available. So you need to use sufficient number of algorithms and then you need to compare them. So how to compare? For comparison, some analysis you need to do. First is error analysis, different types of error analysis. Okay, and the second one is that is that is the confusion matrix. Okay, which is the matrix for the statistical error. Okay, type 1 or type 2 error, the statistical error analysis matrix is there, that also you need to do that. Okay, and some other graphs are also there, you need to check which is giving you the best solution with less number of time. Okay, so writing of paper, you need to do some innovative technique, and you need to means use a innovative data set also. So you need to means first share the data set with us. Let me check that. Okay, also you need to write down the objectives, and if you have any ml technique to means yes, you can use python. It is an open source, you can use. If you don't have the access in matlab, okay, you can use the python. If you use matlab, it is means your difficulty level will be easier, means everything is there. Okay, if you use python, then it is open source, but if you you need to means collect the different programs for means you need to search them. and then you need to apply them. Okay, so use Python also, that is also okay. Okay, so this is the all. Okay, all for today. Okay, I'm going to wind up the class now. Thank you for attending the class.